What's up, guys? Today we'll be doing lesson 8.5. And lesson 8.5 is about trapezoids and kites. Yeah, kites. Like the ones you used to fly when you were small. I don't know. Maybe you still fly them now. Beats me. Yeah, the shape is the same, but we're not going to go outside and fly kites. Alright, so there's two types of trapezoids. The first one is just a regular old trapezoid. And the definition would be that a trapezoid is a quadrilateral. Quadrilateral has four sides with only one pair of parallel sides called bases. And this is what it looks like. And the trapezoid, or a trapezoid, will look something like this. The two bases are right here. They are parallel. They're on the top and bottom, unless it's flipped over, like standing on its legs. The legs are on the opposite side of the base, and the legs will touch each other. The legs are not parallel, only the bases are. This is a basic, simple trapezoid. There really is no property for this. It's just trapezoid. It's a shape. And later on, we're gonna have to find the area. You don't have to write them, I'm just showing you. You're gonna have to make a line right here. Make a triangle over here also. Whoop. Triangle, right triangle. But that's later on, you don't have to do that. I'm just showing you. Alright, the second type of trapezoid is an isosceles trapezoid. And that would be that. An isosceles trapezoid is when the legs and base angles are congruent. The legs and the base angles are congruent, and whose diagonals are congruent. And a picture of that looks something like. So this picture here shows that here are the legs. See the legs? The legs are now congruent, and the base angles are congruent. These are the base angles, the bottom ones. And then of course if you flip it over, that would be the base, but this is the top. So you have two bases really. Just depends which way it's standing or sitting on. So the bottom left equals the bottom right. The top left equals the top right. And later on we're going to go over this. This is four sides, so there should be 360 degrees in here. So all four angles have to equal 360. Now about the diagonals, let me show you a picture of that. Here we go. Now it says the diagonals are congruent. So all of this AC is congruent to all of BD. Whoa, what the heck? There you go. BD. Yeah, I meant to do that. If we were to put a dot here and call it, I don't know, M for midpoint, it's not a midpoint. So I shouldn't call it midpoint. BM does not equal MD. BM does not equal MC. Right? And then, real quick, over the years since I've been teaching trapezoids, a lot of students don't know what a trapezoid is. So they try to think of it as this symbol, which is totally wrong. Let me show you. Watch. I've always had students say like, sir, trapezoid, oh, you mean the Pizza Hut symbol? I'm all like, negative. Nobody, sorry. And they're like, yeah. I'm all like, no, negative. Draw it, and here's the symbol. I don't know. Maybe you don't think it is, but it's not, trust me. This has 1, 2, 3, 4, 5, 6 sides. That's actually a hexagon. A weird hexagon at that. A concave hexagon, but hey, whatever, we're not going over that. So a Pizza Hut symbol is not a trapezoid, people. FYI. Gone. Alright, let's try an example. Here's a trapezoid. This is an isosceles trapezoid because KJ is the same as LM. It has these little symbols, so this is an isosceles trapezoid. And let's find how much is angle L, how much is angle J, and how much is angle M. Well, if K is 50, which one else is 50? This one, L. L is also 50. And I told you earlier, oh, right here actually, everything inside here should be 360. So you have 50, you have another 50. That's 100. 50 plus 50 is 100. 360 minus the 100. These two angles, J and M, have to equal 260. And they're going to be exactly the same because it's an isosceles trapezoid. So 260 divided by 2. 1 is 2. Another 6 is 3. 130. Each one is 130 degrees. Let's try another example. Here's example 2. It's another trapezoid. It's an isosceles trapezoid again because here are the legs. This is just a weird one because it's it's skinnier and taller and it's on its side. So let's find angle L, angle J, and angle M. Some people might say, look, this is 100, so J is 100, but that would be wrong because this is a base. The small one stays with the small one. So K has to go with L. So K is 100, L is 100. Which means that these two have to be exactly the same. And you have 100 plus 100, that's 200. All of it should be 360. That's 160, which means each one of these is 80. And 80. Now, let's go on to something different now. Let's go over something called the mid-segment. It's just like it reads. It's the middle segment of a trapezoid. So here's my trapezoid. My trapezoid is A, B, C, D. This is the base. This is the base. These are the legs. This would be the mid segment. So MN is the mid segment. And MN is parallel to the bases, which means it's never going to touch the top and bottom. And it's exactly in the middle, which means that it cut AD in half, which means that this piece here equals this piece here, and now BN is the same as NC. So let's say from here to here it was 10. Well, that means that each of these is 5. And from B to C it was 18. Well, that means that this is 9 and that's 9. And how do you find this mid segment? It's pretty easy actually. Let me erase these numbers so they're not in the way. To find MN, you're going to add whatever AB is plus whatever DC is and divide by 2. So in other words, let's say this was 7 and the bottom here was 23. This middle, like if this was 7 feet and that were 23 feet, how many feet is this one? Well, you're going to add the top, which is 7, add the bottom, which is 23, and then divide by 2. 7 plus 23 is 30, and 30 over 2 would be 15, so this would be 15. Pretty simple. Let's try some examples where we do this, and I might throw in some X's also to make life fun because it can be boring, you know. So here is example 3. You notice all of these have numbers. You're like, what's going on here? It's the same thing is going to apply. The top one plus the bottom one plus the bottom 15. You divide that by 2. So you add the top and the bottom, and that equals the middle, which in this case is 12.5. So you add the top, add the bottom, add them together, divide by 2, and you get the middle number. Here, we're solving for x. 1 plus 15 here is 16, so I'm going to just rewrite it real quick. So that becomes 3x plus 16 divided by 2 equals 12.5. Now, this divided by 2, it's bugging me. Can't solve with division. Opposite of division is times. So times 2 times 2. 3x plus 16 equals 12.5 times 2. Double 12.5, that's 25. Subtract the 16. 3x is equal to 9. Divided by 3. 9 over 3 is 3. Now, we can finally get to the kite now. A kite, and here is the proper definition for a kite. A kite is a quadrilateral that has two pairs of consecutive sides, but opposite sides are not congruent. The diagonals are perpendicular, makes 90, and the opposite angles are congruent. And I know you're thinking like, what the heck did you just read? It's a pain in the butt to explain something super simple. That's a kite right there. This side is congruent to that side. This side congruent to that side. That's it. This one doesn't equal that one, and that one doesn't equal that. Easy smeezy. Now let me show you two more pictures that explain more about this. Alright, and here are the two other pictures. Here's the diagonals. The diagonals are perpendicular, which makes 4 right triangles. 1, 2, 3, 4. Which means you're probably going to be able to do Pythagorean theorem. And over here, these two angles are congruent. Not the ones on the very far end. They don't have any similarity at all. This is a quadrilateral, so this should be 360 inside. So you'd have to subtract these and try to figure those out. Hopefully they give you one. Let's go over an example or two. Alright, so here is example 4. That's 100, that's 40. Remember, they're not equal. Only E is congruent to, that's supposed to be G. E is congruent to G right here. So we have 140 plus 40 is obviously 140. Now, these two are equal. And this is a quadrilateral. There's 4 sides, so there's 360 inside altogether. Subtract the 140. There's 220 left over. And since these two are exactly the same number, 220 over 2. And that gives you 110 degrees. So angle E is the same as angle G, which is 110 degrees. So 110, 110. Now let's try one last example and we're done. I know you're all excited. And this one's going to be about the diagonals. Example 5. And here we go. Don't forget, diagonals make 90. So all of these have 90 degrees. They're all right triangles. How much is XY? How long is XY? And how long is WX? Don't forget that XY is congruent to YZ. Same number. So they equal a number over here. And WX is congruent to WZ. That's an awful W. WZ. And since we have a right triangle right here, I'm going to do Pythagorean theorem. That's the A, that's the B, and that's the C. 10 squared plus 5 squared is equal to C squared. You put this in the calculator, you get 125. Take the square root. And the square root of 125 for this side right here is 11.1. I hope you just don't write that down. I hope you actually remember how to do that. If not, learn right now. Over here, for this triangle here, that would be my A, this would be my B, and I'm looking for C. So it'd be 10 squared plus 19 squared equals C squared. And 10 squared plus 19 squared is 461. You take the square root of 461 and it gives you 21.4. Alright guys, see you in class. Hope you bring your notes. Laters.